Hello students, in this session we are going to see about the introduction of mechatronics. Mechatronics is a subject in 7th semester. The subject code is ME8791 and we have 5 course outcomes. The first course outcome is the first unit, which demonstrates the fundamental knowledge of sensor, actuators and associated control systems. The knowledge level is K2. The second unit deals with the appropriate sensors and actuators in automatic systems. The knowledge level is K3. The third unit explains the use of various controllers to control the various mechatronic systems. The knowledge level is K2. The fourth unit deals with the simplification of system with programmable logic controller, that is PLC. The knowledge level is K4. And fifth unit applies the fundamental principles of integral design in practical problems related to automation systems. So these are the 5 COs in mechatronics subject. The next tabular column is the mapping of course outcome with program outcome and program specific outcome. So in the first unit we are going to see about 5 important topics. The first topic is Introduction to Mechatronic Systems, the concepts and its application. The second topic is the mechatronic system with components and some examples for the components in mechatronic system. The third topic is measurement systems, control systems, open and closed loop system. The fourth topic is sequential controllers with some examples like water level controller, etc. And the fifth topic is the sharp speed control and washing machine control system. So these are the 5 topics in first unit. So what is mechatronic system? The word mechatronics is originated from Japan, that is Ashikawa Electric Company, in 1960s, which then spread through Europe and now commonly used around the globe. The word mechatronics is composed of mecha from mechanism and tronics from electronics. Mechatronics solves technological problems using interdisciplinary knowledge consisting of mechanical engineering, electronics and computer technology. In 1996, Tomishika, Harashima and Fukuda defined mechatronics as the synergistic integration of mechanical engineering with electronics and intelligent computer control in the design and manufacturing of industrial products and process. Bolton presented yet another definition by saying a mechatronic system is not just a marriage of electrical and electrical mechanical systems and is more than just a control system. The mechatronic system is a complete integration of them all. Mechatronics is a field of study concerned with design, selection, analysis and control of systems that combine mechanical elements with the electronic components, including computers and microcontrollers. So this is a diagram representing the graphical representation for mechatronics. It consists of information systems, mechanical systems, computer systems and electrical systems. The representation shows the synergistic integration of sensors, actuators, signal conditioning, power electronics, decision and control algorithms and computer hardware and software to manage complexity, uncertainty and communication in engineered systems. It consists of control system, control electronics, electromechanics, mechanical CAD, digital control system. The combination is called mechatronics. So the disciplinary foundations of mechatronics are mechanical engineering, electrical engineering, computer engineering, and computer information systems. So these are the four disciplinary foundations for mechatronics. Evolution of mechatronics. The technological advances in design, manufacturing, and operation of engineered projects, devices, and process can be traced through Industrial Revolution, Semiconductor Revolution, and Information Revolution. The first one, Industrial Revolution. The allowed design of products and process for energy conversion and transmission by allowing the use of energy to do useful work. Engineering designs of this era were largely mechanical, like operations of motion, transmission, sensing, actuation, and computation, which were performed by mechanical components like cams, gears, levers, and linkages. The purely mechanical system suffer from power amplification inability, energy losses due to tolerances, inertia, and friction. So these are some of the examples of predominantly mechanical designs. The first one is the float valve. The second is a watt governor. Third is a cam operated switch. Fourth is a bimetallic strip. And the last one is the thermostat. So these are some of the mechanical designs which are predominantly used. Semiconductor revolution. LED to the creation of integrated circuit technology. LED is light emitting diode. The effective minimized power electronics could amplify and deliver needed amount of power to actuators. The signal conditioning electronics could filter and encode sensory data in analog or digital format. The hardwired onboard discrete analog or digital ICs or integrated circuits provided rudimentary computational and decision-making circuits for control of mechanical devices. First one is an integrated circuit. The next one is an A to D, that is analog to digital converter. And third one is an operational OM. In industry information revolution, the development of VLSI technology led to the introduction of microprocessor, microcomputer, and microcontroller. Now computing hardware is everywhere cheap and small. As computer hardware can be effortlessly interfered with real-world electromechanical systems, it is now routinely embedded in engineered products or process for decision making. So microcontrollers are replacing precision mechanical components like camshaft in many applications functions for timing device. The programmability of microcontrollers is providing a versatile and flexible alternative to the hardwired analog digital computational hardware. The integrated computer electrical mechanical devices are now capable of converting, transmitting, and processing both physical energy and virtual energy. Therefore, high efficient products and processes are now being developed by judicious selection and integration of sensors, actuators, signal conditioning, power electronics, decision, and control algorithms. So mechatronics has evolved through the following stages: primary level mechatronics, secondary level mechatronics, tertiary level mechatronics, and quaternary level mechatronics. Primary level mechatronics integrates electrical signaling with mechanical action like fluid valves and relay switches. Secondary level mechatronics integrates microelectronics into electrically controlled devices like cassette player. Tertiary level mechatronics incorporates advanced control strategy like microelectronics microprocessors into specific integrated circuits, for example, microprocessor based electrical motor for actuating purpose. Quaternary level mechatronics attempts to improve smartness a step ahead by introducing artificial intelligence artificial neural network or fuzzy logic and fault detection and isolation capability into the system. Mechatronic applications like computer disk, VCRs, ATM in medical implant devices, in defense, UAV, unmanned vehicles, underwater vehicles, manufacturing, CNC, NC, rapid prototyping, automotive like climate control, anti-lock brake, safety, engine management, and network centric like distributed systems, distributed robotics, intelligent highways, electronics are some of the applications of mechatronics. The first example of mechatronic system is a robot. A robot consists of several chips and several components like leg, head. Each and every one is a sensor like light sensor, proximity sensor, sound sensor, temperature sensor, etc. Example 2 for mechatronic system is motion and force control of an indirect drive robot. Third example is a program to track straight line, that is program for collision avoidance in outside corridor. The fourth example for mechatronic system is a computer disk drive with an example of rotary mechatronic system which requires accurate positioning of the magnetic read head, precise control of media speed and extraction of digital data from magnetic media. Fifth example is a washing machine which requires understanding of load size, receptacle to hold clothes, plumbing, agitation of drum, ease of use, reliability, low cost. The actuators in washing machine are AC or DC motors, water inlet drain. The sensors used are water level sensor, load or speed balance sensor. So this is a diagram representing the microprocessor and amplifier, which is the control system, and the motor and the sensor is an actuating device, and the load is given in the drum. So some advantages of mechatronics are cost effective and good quality products can be made, high degree of flexibility to modify or redesign, very good performance characteristics, and wide area of application for greater productivity in manufacturing organization and greater extent of machine utilization. Some of the disadvantages are high initial cost, need of highly trained workers, multidisciplinary engineering background, and complexity in identification and correction of problems. Thank you.